Hi, everybody. I'm Jason Puar, and this is the Asia Ventilation Forum, or the AVF Podcast. Today's behind-the-scenes ICU Stories is titled A Lifetime of Research on Nutrition and Critical Illness. And we are very glad to have Dr. Daren Heyland. Hello, Dr. Heyland.
Hi, thanks for having me.
Thank you. Dr. Heyland is a professor of medicine and epidemiology at Queen's University in Kingston, Ontario, Canada. And he's trained in internal medicine, in critical care medicine, and in clinical epidemiology. He currently serves as the director of the Clinical Evaluation Research Unit at Kingston General Hospital. He's the principal investigator on a number of large-scale multi-center clinical nutrition research projects. And he's published approximately 450 peer-reviewed papers. He's raised more than 120 million in external grant support, and he's given more than 350 international presentations. So, Dr. Heyland, you are a well-known name in critical care research and critical care. And a lot of the work that you've done has been on nutrition in the critically ill. So I guess the first question that I have to ask you is, what inspired you to start doing research in this area all those years ago?
Yeah, and that was a long time ago, so it's sometimes hard to remember the initial steps of one's path. But I came into this through the back door, if you will, in the sense that I never had any formal nutrition training. My training was in clinical epidemiology. And I started my career very interested in nosocomial pneumonia or ventilator-associated pneumonia. And through the early work I was doing, recognized the role of the gut and of nutrition in increasing the risk of ventilator-associated pneumonia. And as I, from a scientific, evidence-based, critically appraised, sort of the nutrition literature and, why are we feeding people like this when it can cause harm, through increased risk of pneumonia, I realized that there was a dearth of evidence in this space of critical care nutrition. And so I kind of stumbled on it, meaning like no one was really doing evidence-based medicine in critical care nutrition. And because it linked to at that time, my primary passion of ventilator-associated pneumonia, I got started in trying to examine different constructs and attest certain assumptions, challenge certain assumptions in the nutrition space. And one thing led to another, and here we are 25 years later, and I've probably done more than 25, possibly 30 randomized controlled trials in that space of critical care nutrition.
Wow. Right. And amongst those 25 or 30 trials, 4 of them were published in the last couple of years.
Yeah.
It's almost like a combination of your career, right? Yeah. I'll just read them out just for the audience. So there's the Re-Energize on enteroglutamine for burns in New England Journal of Medicine, 2022. Yeah. There's Sustain CSX on high-dose selenium for cardiac surgery, JAMA Surgery 2023. There's LOVIT on intravenous vitamin C for sepsis, New England Journal of Medicine 2022. And there's EFFORT, which is high versus usual dose protein dosing for critical illness, published in the Lancet 2023. Could you share your key takeaways from these studies?
Yeah. And I'd like to start with answering that in a little bit of a different way, because if you kind of just look at the abstract and read the results of those trials, it's rather deflating and rather, okay, so what, move on. But there's a lot of backstory to those trials. And the process that I've been working and believing in and working on is, we have these building blocks to our knowledge, and we layer on sort of a base understanding of the basic science, the mechanistic science of how nutrients or nutrition, might impact the underlying disease process and therefore impact outcomes. And then we systematically review existing RCT level of evidence in the form of meta-analysis to, again, build a story or highlight a signal that then generates enough interest in testing a hypothesis in a large-scale clinical trial. And that process, and there's one other process that's happening along the same time, and that is building networks. That is, meeting colleagues who share a similar interest, getting them engaged and excited about a particular research question, so that at one point you arrive at this place where, okay, we have the wherewithal to do a large-scale trial to test a singular hypothesis. In the example of the re-energized trial, that was an effort that took 13, 14, 15 years from start to finish of, getting interest. One of my colleagues, Dominique Garrel from Montreal, did the single center pilot trial of enteroglutamine. Other people were doing similar single center. We meta-analyzed them together. We had just finished our own glutamine trial in the ICU setting. And we said, well, we should further explore this role of glutamine in critically ill burn patients. And what we ended up doing, which was published in the New England Journal of Medicine, was pulling together over 60 burn units around the world to do the largest ever burn trial, 1,200 patients. From the day the first patient was enrolled to the day the last patient enrolled took 10 years. And so it's a real labor of love and a real collaboration from many, 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 many people. Unfortunately, or I don't know, it depends on how you look at it, we weren't able to demonstrate any benefit to enteroglutamine in the re-energized trial. And so, I mean, it answered a clinically important question, but the beauty of it was the process of examining the underlying science, building the collaborative network, obtaining the funding, and executing the trial. And that if you just read the abstract, you don't get that whole story. And so I wanted to share that. And in a way, each of those 4 large-scale, multi-center, multinational trial, I could say the same thing. We build the idea on the underlying pathophysiology, underlying mechanisms by why we think these nutrients might work. We systematically review existing RCT level of evidence in a hypothesis generating way to say, oh, it looks like there's a signal here. We need to do the large scale trial to confirm that. So same thing happened with high dose intravenous selenium in high risk cardiac surgery. You may appreciate that there's a lot of selenium research in sepsis that at the end of the day didn't show any benefit. But one of the challenges in sepsis, and listeners will appreciate this, is the heterogeneity of sepsis, and people at the point of presentation in an ICU where they could be recruited at a trial are in different stages of inflammation and immunity. And so when you give a nutrient that has a specific physiological effect to reduce inflammation, attenuate oxidative stress, it may be a good thing at a particular point in time, whereas it may be a harmful or a neutral thing at a different point of time. And so when you have that kind of heterogeneity in sepsis, it may explain why the existing trials in sepsis were neutral. And we liked and were attracted to high-risk cardiac surgery as a model of, I know exactly when the inflammatory state started. In fact, I can pre-treat and then treat right after and then continue that treatment to try and attenuate that stress response, reduce inflammation, improve organ function. So we are very excited, very hopeful that the SUSTAIN cardiac surgery trial of high-dose intravenous selenium that was published in JAMA Surgery would be positive, but in fact, it wasn't. We didn't show any material benefit clinically to using the high-dose intravenous selenium. And I think, one thing we're still trying to figure out is how we enrich the patient population to get the patient group that will benefit the most. Although we focused on high risk, what we thought was high risk at that time, in fact, a lot of patients sailed through their surgery. And so it's going to be hard to show an impact of a nutrient or a drug in patient groups that don't experience adverse events. And so our existing program of research in cardiac surgery is trying to refine our understanding about what we really mean by high, or said differently, how we even subselect out a higher risk population that where we may be able to show a role with nutrients or other drug strategies. And that's probably a good segue into talking about the EFFORT trial, which was high dose protein versus usual care dose protein. And what was unique about this trial, well, there's several unique features about this trial, but the one that I'll speak to first, which relates to what I just said about high-risk cardiac surgery, is patient enrichment strategies. Because historically, we had thought that all ICU patients are the same with respect to their risk of nutrition consequences. If I don't feed my patient adequately, they'll have bad things happen to them. All ICU patients are at this risk, therefore we should feed them and expect that they will all benefit the same from our artificial nutrition strategies. And I challenge that assumption, and I've been doing a lot of work on nutritional risk stratification in ICU patients. And so we set up the EFFORT trial to include only nutritionally high risk patients. Prior trials of critical care nutrition, where people do large scale nutrition trials, have just sort of taken all comers who are ventilated and in an ICU, thinking again that they're all the same, all have the same responsivity to nutrition. And so we intentionally sub-selected out what we thought were the nutritionally high risk patients, randomized them to high protein, 2.2 grams per kilogram per day, or usual care, 1.2 grams per kilogram per day, to try and get a separation in the two groups. Achieved a reasonable separation of 0.7 grams per kilogram per day difference between the two groups. But quite disappointingly, again, no difference in the clinical outcomes that we were able to examine as published in the Lancet, which is mortality, time to discharge alive, and other sort of traditional length of stay variables. That doesn't mean that protein isn't helpful or impactful. It just doesn't, it means that it's not going to impact mortality. And we continue looking at the role of high dose protein on other functional or performance-based measures. If you will, protein may attenuate the loss of muscle and aid in the recovery process of a critically ill patient. And so and I might come back to that if you ask me about future research questions, because that's one of them that's super important. I want to just make one other comment about the EFFORT trial, and then I'll talk about the vitamin C work, and then I'll take a breath and we can stop and see where we go next, Jason. But it would be wrong of me to even breathe about the EFFORT trial without acknowledging again the tremendous collaborative spirit that exists in the critical care nutrition community. Over the years, I had been doing what was called the International Nutrition Survey, which was a quality improvement project, which really was an audit of nutrition practices. And I would feed back to sites how they fed patients and what their outcomes were, and benchmark that to peers. And so people could see how their nutrition practices compared to, their peers, as a way of saying, well, maybe we should pull up our socks and maybe we could do a little bit better. And over the years, probably had over 800 ICUs around the world participate at one time or another in that collaboration. And at one point, I conceived of the idea and I said, I wonder if I can do practice-based research. I wonder if I can randomize people in the context of this registry of nutrition practices. And along with many colleagues and the American Society of Parenteral Enteral Nutrition, we moved forward to do that exactly. And that's what EFFORT represents, was a huge effort on many people's parts, because they voluntarily contributed data as if it were part of a registry. But the only thing that made it a randomized trial was I constrained people to prescribe high or usual care, because our audit data showed that was the range of practices. And so I basically, took the top end of the range, the bottom end of the range, and constrain people to be randomized. And everything else was as per usual clinical care, and everything else was as per usual clinical data collection for that audit. And so kind of a unique way to do a large-scale RCT, which again was very gratifying in the process of doing the trial, a little disappointing with the results. Speaking of disappointment, that leads to the last trial that I'll mention, and that's the Lovett trial, which was high-dose vitamin C in sepsis. And this again is building off of the underlying mechanisms underlying prior RCTs done in the field, where we thought, this strategy of high-dose vitamin C would be beneficial in sepsis patients. And unfortunately, no, we couldn't demonstrate a positive treatment effect. In fact, maybe a little signal towards harm, although we can talk more about that if you're interested. But again, we were left with sort of a, does nutrition and do nutrients actually affect outcome? And that's kind of the bottom line conclusion of my lifetime work, is still left wondering if nutrition does impact outcome, or do we need a new paradigm, a new approach to the research so that we can better demonstrate that these nutrients and these nutritional strategies matter. So I'll stop there and see if you have any follow-on questions.
Yeah, I regarding the effort study, I was quite struck by the subgroup analysis, where high-dose protein seems to be associated with worse outcomes in patients with AKI and multi-organ failure. Because I would have thought that it would be the opposite, where patients with AKI, maybe those who are on kidney replacement therapy, a lot of catabolism, and we give them higher dose protein. Could you share your thoughts on that?
Yeah, and of course we built the whole hypothesis and the need for the trial based on conflicting signals, that some patients seem to be harmed by increased protein. Some studies showed increased harm with high dose protein, some showed increased benefit. And so we have this condition of equipoise, and we didn't really have any large scale RCTs. And this is the first, large scale RCT testing this hypothesis. And to my surprise, again, I admit I was wrong, because I thought too, highly catabolic patients with a high Nutrix score, which was the score that I developed to try and categorize people, those that would benefit the most from high dose nutrition, including high dose protein. We didn't show that. We didn't show that those catabolic, sick, long staying ICU patients, benefited the most. In fact, we had a harm signal in people with AKI and people with high SOFA scores. And so so we know that now, and that's useful, that's helpful, that'll be informative to guidelines. And I think what and I don't have mechanistic data in the context of this large scale pragmatic RCT to explain that harm signal. But if we just step back conceptually, when the body is severely inflamed, very catabolic, taking and incorporating de novo protein and building, that for visceral or skeletal muscle proteins that are going to have a positive downstream effect is not happening. The body has to be resolving from its critical illness before it can use that protein for adaptive purposes, is what I'm seeing and what I'm saying. And so even moving forward in this protein RCT research, we don't include patients with AKI, and clinically I would use a usual or a low dose protein until I see that resolution of the organ failure or a resolution of inflammatory markers, if I'm following that, before really, pushing up the protein to aid in the patient's recovery. And so there's still a lot of unknowns about the protein story in terms of timing. Maybe high dose protein is better later or mid to later in critical illness. Maybe high dose protein minus out the kidney failure people, it will aid in the recovery by retaining muscle. And so these are the open questions that remain in the protein story. But for sure, what we know now is that, those highly catabolic patients, the sick patients, the inflamed patients, the patients with organ failure, don't push the protein in them. They can't tolerate it. They can't metabolize it in a way that is beneficial.
Right, right. I've been reading your papers, and as you and your colleagues say in some of the papers, it's often when you perform these large multi-center trials that you get the quote-unquote negative results as compared to the small single-centered ones. Why is this so?
Yeah, and if I knew the answer to that, I'd be super excited. But it is what we observe again and again, that in the single center trial where you have less heterogeneity or less variability in how things are done, how the nutrient might be applied, the kind of patient subgroups that you see in a particular single center ICU. And so with that less noise, you may be able to better see a signal relative to the noise in a trial. That's the whole goal with these large scale trials, is signal relative to the noise, because there's a lot of noise with the different patients, different processes of care, different, even in our vitamin C work, different vitamin C substrates in different parts of the world that come from different companies. They may not all be the same in terms of their efficacy and safety. And so all those differences come into play when you move to a large scale multi-center paradigm. And so you have a lot of noise. And what we're not able to see is that signal through the noise, if there is a signal. Back to the single center trials, there's also a lot of more opportunity for bias, either unintentional or intentional, where because, getting a positive trial is easier to get, having a positive trial is easier to get published and promoted, there's a potential for bias or even fraudulent results, if you will. And so if you're trying to make inferences on how to manage, people across ICUs, whether those are national guidelines, international guidelines, of course, you don't want to make an inference, based on a single center trial, what the experience of that nutrient in that trial in that center. And so we do need, large scale trials. In fact, some guideline developers say we need more than one. We need two, a minimum of two large scale multinational trials to have high level confidence, in the clinical guidelines that we develop for the management of groups of patients. So we need these large scale trials, but is there something wrong with the way we're designing them or conducting them that is allowing us to not see that signal relative to the noise in this critical care nutrition space? Or is it that nutrition doesn't matter? And that's the tension that we have right now, given all of these large scale negative trials.
Right. Well, fascinating. Or is it that nutrition doesn't matter?
Yeah.
By Dr. Daren Heyland. Wow.
Well, I gave a talk at a international meeting just a few months ago where I raised that, it was about, reviewing all these negative trials, and either nutrition doesn't matter or our approach to detecting the impact is flawed, and we need to modify our approach. And for example, I'll just again come back to the protein story, because it is plausible that protein doesn't, in this instance, impact mortality and length of stay for most ICU patients. What it's impacting is the muscle and the performance and the recovery. And so, why design a mortality-based trial for protein when in fact it's a different outcome? And so we're getting more sophisticated in our evaluation frameworks. I could say the same about selenium and organoprotection, that maybe it's not about mortality, but rather looking for early biomarkers of organ injury, and then a later stage, organ injury defined by the use of life-sustaining treatments. And we've evolved this concept of persistent organ dysfunction plus death as a composite endpoint. And so we're refining our endpoints to better detect those potentially positive treatment effects of nutrition. And so that work needs to continue. Maybe I'll just jump ahead too, because I know you're going to ask me about the future.
Yes.
And say that I think one thing that we're desperate for in critical care nutrition are biomarker-led definitions of more homogeneous subgroups of patients at a particular course of their illness that then, okay, now we know I can apply a nutrient or a nutritional strategy and it will have a positive treatment effect. If I can give a clinical example or a research example of recent work done by the Swiss team that looked at intensive medical nutrition in hospitalized patients and showed that by augmenting artificial nutrition support through the course of a hospitalization, they had a positive effect on survival. But then in a subgroup analysis, they showed that nutrient strategy, that nutrition strategy was ineffective in people who had a high baseline C-reactive protein, whereas all the positive treatment effect was derived in people who had minimal to moderate levels of inflammation, again, as judged by baseline C-reactive protein. Now, so think of that as an example or as a prototype of a paradigm where we're measuring something in that biological response to critical illness that indicates, oh, okay, at this point in time for this patient, this nutritional strategy would be beneficial. So that I feel like is where we need to go in the future to better define the subtypes of patients that will benefit from specific nutrient strategies on the better evaluation frameworks that we're evolving.
Right. And so are some of these studies being planned at the moment?
Yeah. Another part of that international meeting we had a couple months ago was to develop protocols that are more aligned with this sort of precision medicine approach. Again, for example, one of my colleagues from Malaysia, Zheng Yi Li, is working on a project looking at the use of fish oils in people who are inflamed as expressed by a high IL-6 or a high CRP. And can I convert someone who's inflamed and probably not benefiting from artificial nutrition to someone who is less inflamed and now ready to absorb and assimilate and utilize artificial nutrition. And so again, using those inflammatory biomarkers to identify a subgroup of patients who are not responders, but using an anti-inflammatory strategy with fish oils to see if you can convert them. So just an example of one biomarker centered, RCT that's under the design stage.
Right. So could you share your thoughts on what are some of the areas that really should be studied in the near future in critical care nutrition?
Yeah, I mentioned a little bit before about the importance of still continuing with the protein story,
right,
and exploring timing issues,
right,
and exploring the dose in the context of muscle and the recovery. And so where 6-minute walk tests or muscle strength, functional status at 6 months become our primary endpoints. And those trials are ongoing in our research paradigm. We still continue looking at high-risk cardiac surgery. One of my colleagues, Christian Stoppe, is leading a program of research where, again, with vitamin C, with fish oils, and maybe one day with selenium again, but not right now, looking at an enriched cardiac surgery population of whether these anti-inflammatory oxidative stress type molecules, nutrients, would be beneficial. And so that program of research continues. I might just say one more thing about vitamin C, in that the 2 trials that I've been involved in, published in the New England Journal, have not been beneficial. But there's a whole other body of evidence from many other people's work that does suggest benefit. And when we put those together in a meta-analysis, and we just published this last week, we still see a positive signal, even when you include the Lovett trial in the existing monotherapy intravenous high-dose vitamin C trials in sepsis. And again, is the problem with the vitamin C literature because it's sepsis and because of the heterogeneity? And so we've pivoted again away from sepsis, and I mentioned Christian's work in high-dose vitamin C in cardiac surgery. I too, and working with Christian and a few other people are continuing high dose vitamin C in severe burn patients. It's called the Victory Trial. We're just starting out. We've only got almost 50 patients enrolled. I hope it doesn't take us 10 years, but yeah, we're following on the Re-Energized network to explore the role of high dose vitamin C in this burn population. And so we're looking to figure out the right nutrient at the right dose and the right timing in the right sub population, so that future guidelines will be more informative.
Right. It's very much about precision medicine, right?
Yeah.
Yeah.
Yeah, that what I just said there is very aligned with precision medicine.
Yeah. Yeah. So could you share your thoughts on I don't know, just reflections on all these decades of work? Any tips or advice for aspiring clinicians and researchers?
Well, couple of thoughts. Yeah, building to the stage of my life where I was able to do, these large scale projects and then having them all negative and not support, my prevailing hypothesis or our prevailing thoughts on the merits of these nutrients was quite disappointing. And so it makes one wonder, about one's life's contributions, when all you've been doing is proving that things don't work. But I really want to speak to the process, and I tried to highlight that in my earlier comments. That I think my main contribution to this nutrition space, and I'm active in other spaces too, but as it relates to critical care nutrition, when I arrived on the scene 25 years ago, the average sample size of a nutrition trial was 40 patients, 20 patients per group. The outcome measures were serum levels of something, or some mechanistic outpoint like inflammatory marker or nitrogen balance, something like that. And we were making inferences on how to manage critically ill patients. Our guidelines at that point were informed by that kind of trial. That was 25 years ago. And so, I came into this space because I was a disciple of clinical epidemiology, of, evidence-based medicine. And I applied those tools to this space. And we developed the first evidence-based critical care nutrition guidelines back in 2003. The concept of taking systematic reviews or meta-analyses of RCTs and using those to inform clinical practice guidelines, and being very transparent when we didn't have enough evidence to say something, in contrast to prior guidelines where it was all opinion-based, based on our understanding of underlying physiology. And so and now to today, where we are generating large-scale RCTs as a part of the way we do business. And so I think my contributions over the years are measured in that transformation of very much opinion, expert-based medicine based on physiology to a place today where we have, more RCTs, more systematic reviews of RCTs, better evidence-informed guidelines, and an ongoing pursuit of knowledge. And that's probably what I would encourage junior people to do, is to remain curious, challenge assumptions, make sure we have a solid evidentiary basis, whether that's in nutrition or anything else that we do in the practice of critical care. I remember one anecdote of when I was rounding with a young team of residents, and I'm not going to go into the details of the clinical problem, but I asked this resident, well, what do you think we should do next? And she said, we should do this. And I said, well, why do you think we should do that? And her answer was, well, because that's how Dr. So-and-so does it. As if the evidence for doing something is what you see the other person do. And I was discouraged by that paradigm and feel like we need to be more cognizant of the scientific evidence supporting different treatment practices, and really understand that, and really be curious about whether that's true or not. And if someone has, that passion to really explore that further, then get the research training that gives you the toolkit to continue to test and retest and evolve the nature of our knowledge in critical illness. But if you just come into critical care thinking that whatever Dr. So-and-so says is the way it is, I don't think you'll be practicing good medicine, and B, you'll miss an opportunity to participate in a discovery process, a discovery machine that leads to new knowledge. And in ICU, whether it's nutrition or ventilation or sepsis or whatever, there's lots of these discovery machines happening worldwide. And so it's exciting to be a part of it. But you have to stay curious and really understand evidence and the creation and evaluation of evidence to be a part of that. I hope that was useful.
Oh, that was super useful. And even though you very humbly said and questioned yourself about all these so-called negative studies, I would say, number one, that years ago when I was a young intensivist, and many of my colleagues, right, we read your guidelines, your evidence guidelines, right? We practiced according to these guidelines. And then, as some of us went into a little bit of clinical research, we actually modeled our research methodology according to what you did. It's very programmatic, right? It's not just one study and then that's the end of it. It's an entire program of research. And even today, 2023, when we read the effort study, we are still changing our practices according to the evidence you have generated. So now I'm not going to give high dose protein for anyone with severe AKI anymore. And we continue to look forward to the work that you and your team will be doing in the years to come. So yeah, really, thank you very much for talking to us, and more importantly, for your life's work, which has really changed practice in a very positive way. So thank you very much.
That's very kind of you to say and acknowledge that. I appreciate that, Jason.
Yeah, and I'm sure I'm speaking for many people in ICUs around the world. Thank you, Dr. Heyland. Yeah.
Okay, it's been a pleasure. Thank you.
Thank you. So with this, we've come to the end of the AVF podcast. This is available as always on YouTube and Spotify. So please feel free to share it with your friends and colleagues. Till the next time. Bye.
Okay.
Thanks. Bye.
Thank you. Bye-bye.
Thanks, Dr. Heyland. Thank you.